let's discuss few miscellaneous sums, right? That is combination of all the shapes that we learned so far. For 1 mark question, these questions can come. Let's start. The radius of the sphere. Okay, so shape is sphere. So we have sphere here. Let's write sphere it is. What about radius? Let's see. The radius of the sphere whose volume is, okay, so volume is what? 12 pi centimeter cube. 12 pi centimeter cube is dash. Okay, so we need to find the value of radius. Very simple question it is. Very simple. Let's start with the question. Volume of sphere. So let's write with the formula. Volume of sphere. What's the formula for sphere? That is 4/3 pi r cube. Okay, so volume of sphere, it is 12 pi. So 12 pi is equal to 4/3, here pi and here r cube. So pi will get cancelled. Very good. So 12 into 3, denominator 4, is equal to r cube. So 4 1s are and 3s are. 3 3s are 9 is equal to r cube. So you need to take the cube root on both sides, here and here as well. So here you will get 9 and cube root, so is equal to r. Now when you see in the options, this kind of answer doesn't exist, right? So you need to simplify further. How can you do that? See, 9 can I write as 3 square, right? Now 3, 2 divide by 3, because okay, 3 square and cube root of 3. So when you see in the answer, there is a one answer like this. And don't forget the value of r is, let's write in unit, 3 raised to 2 by 3 centimeter. Simple. The method is very simple. So the value of radius, this simplification is important at this step based on the options given over here. So this is how we find the value of the radius. This is 1 mark question, right? That is possible, nothing else, not any detailed one, but this simplification plays important role over here. Let's do the next question. Let's do one more small question, right? Let's read the question. A spherical metal ball of radius 8 centimeter. Okay, so there is a one sphere, right? And radius is given, not diameter. Radius 8 centimeter is melted to make 8 smaller identical ball. Okay, so right now you have one spherical ball, and you are making how many out of that? 8. 3, 4, 5, 6, 7, 8. So we are making 8 balls identical. Okay, identical balls means they are same in size. Good. The radius of the new ball is, we need to find the radius of this new ball. We have radius of this big ball, right? That is 8 centimeter. So how shall we do? Again, we'll go for the volume conversion. We are melting it. So melting means what? This volume will be divided into 8 different balls, right? So let's start. Volume of bigger ball is equal to 8 times. Why 8 times? Because we are making how many balls out of it? 8. 8 times volume of smaller ball. Simple. So here, what's the formula? 4/3 pi capital R cube is equal to 8 multiplied by 4/3 pi small r cube. We want to find the value of small r. See, 4/3 cancel, pi cancel. R cube is what? 8 cube. So we can write 8 into 8 into 8, and here 8 multiplied by r cube. So here 8 into 8 into 8, denominator 8 as well, so r cube. 8 cancel, 8 8s are what? 64. Now guess here, It is cube, not perfect square. So don't write 8 as the answer. It is cube over here. So cube root here, and so do cube root here. So that is 4, and here r. So what's my value of r? Which is r is equal to 4 centimeter. What is the uniqueness about this question is that so far we were given radius and we were finding the value of number of balls, but here number of balls are given and we need to find the value of the radius for the smaller balls, right? So let's repeat one more time. This ball is being melted into smaller ones. So what we have done, volume of bigger ball multiply by how many balls? 8 balls given into question, identical, same in size. 8 multiply by volume of smaller ball. So this you do simplified, 4 by third, 4 by third cancel, pi cancel, substitute the value and get the value of r. So we will be able to make new ball with the radius 4 centimeter. Let's discuss the last question of this chapter. Then we are going to wind up the chapter, done with the chapter. Two right circular cones have their heights in the ratio 1 by 3. So this is a comparison sum because it is given two right circular cones. So let's talk about cone 1 and cone 2, which is cone 2. Done? And okay, let's write few information here, which is, let's say, h2, r2, and here height h1, r1. Now relation is given between height. The ratio in their height is 1 by 3. So can I write h1 by h2 is equal to 1 by 3, right? And radii in the ratio 3 by 1. So radii, which is r1 by r2, which is 3 by 1. Now what is the ratio of their volume? Okay, it is being asked what is the ratio of their volume. So let's start with the ratio. I'm going to take ratio of volume of 1 divided by volume of 2. So let's start. 1/3 pi r 1 square h1. Denominator about 2. 1/3 pi r 2 square h2. Now let's do cancellation. Whatever is similar, we'll remove it. Like pi is similar, 1/3 is similar. So what's left? r1 square, r2 square. So can I write r1 by r2 whole square into h1 by h2? Simple. Let's write equal to sign over here. So r1 by r2, what's the value? 3 by 1. So 3 by 1 square. And h1 by h2, 1 by 3 it is. So 3 square. So can I write 3 into 3? And here 1 by 3. 3 cancel. So what's the answer? 3 by 1. So ratio of volume 1 to volume 2 is 3 by 1. That's my final answer. If you can write here as well, V1 by V2. Now remember here, we use the same formula because the same shape is given, cone over here. Let's recall the steps. First, ratio is given, there are no specific value like h1, h2, r1, r2. So write in a proper way so you can understand it. Afterwards, it is given, we need to find what is the ratio of the volume. So obviously start with the volume, take the ratio. If there is any common quantities, remove them, cancellation. Then substitute the values which is given over here. So this is here our chapter number 13, surface areas and volumes is over here. What we discuss in this chapter, surface area and volume related to few shapes that we were already aware of it. Cube, cuboid, cone, cylinder, sphere, hollow cylinder as well at some point. Then we learn about the volume conversion. If we are melting a one shape and we are converting into another one, what are the dimension of it? Some quantities are given, some quantities are missing. Then we learn very important concept this year, which is volume and surface area related to first term. There are chances of coming this kind of questions. Very important because this topic is there in grade 10. So this is the chapter number 13, surface areas and volume.